WebAssembly began as a browser curiosity, Doom in a tab, Kiadi inside a canvas. Now that same wasm file is landing in server racks. The pitch is concrete. Container images measured in hundreds of megabytes shrink to megabytes or less. Cold starts drop from seconds to milliseconds. Isolation moves from a process boundary to a sandboxed module boundary. It will not replace every container, but for density, speed, and isolation, enterprises are no longer just watching. They are evaluating. A raw WASM module is just bytecode and linear memory. Useful, but blind to the outside world. The component model wraps it as a self-describing component with typed imports and exports. The contract is written in WAT, the WASM interface types format. YT defines records, variants, resources, and functions in a language-neutral way. The runtime then lifts and lowers rich types, strings and lists, into the flat linear memory that core WASM understands. So a Rust component can call a Go component without either knowing the other's language. This is the foundation of WASI Preview 2. Files, clocks, sockets, and HTTP are exposed as UAT interfaces that a component must explicitly import. No import means no access. That is deny by default, capability-based security. The component model needs a runtime. Two platforms are making it production real. wasmCloud is a distributed actor platform. Stateless actors declare capabilities through WAT interfaces. Capability providers immediate access to HTTP, key value, messaging, and files. Hosts connect over a NAT lattice, so the same actor runs at the edge or in the cloud. Spin is a developer framework built on triggers and components. HTTP, Redis, NATs, MQTT, cron, or key value events fire into a WASM component. In Python, you write a normal handle request function, return a response, and Spin maps it to wasmTTP incoming handler. The spin.toml manifest routes hello to the component and runs componentize pyt package Python bytecode into app wasm. Then spin build and spin up give you a local server. Deploy to Fermion Cloud, Kubernetes via SpinCube, or self-host. wasmCloud for distributed actors. Spin for event-driven functions. Enterprises are exploring WASM for four things: microservices consolidation, plugin systems, multi-tenant isolation, and supply chain verifiability. The shared value is near-native performance, millisecond cold starts, and a smaller attack surface than containers or VMs. But gaps remain. Component composition, observability, and language toolchain completeness are still catching up. The honest takeaway is not to replace everything. It is to evaluate WASM selectively for workloads where density, speed, and isolation matter most.